Hello, good morning all. My name is Julien. I'm one of the 3 co-founders at Argent. And for those of you who know me, I love to talk about wallets and I love to talk about account abstraction. And this talk will be no different. I will be talking about wallets and I will be talking about account abstraction. But I don't want to talk about wallets in general. I want to kind of reflect on a concept that I find in talk is the invisible wallet. But before we discuss on how to make the wallet disappear, I just want to actually give you what I believe is a wallet, because we need to agree on a definition to make sure we are all on board and all aligned on what needs to disappear. So for me, a wallet is a client software that manages one or more accounts, and that leads to the definition of an account. An account is an on-chain object that holds the state of a user's identity and assets. And so basically, we have really 2 components. We have the account that lives on-chain, and then we have the wallet, which is the software that the user uses to interact with this account. And we tend to see these 2 things are actually one thing, to merge them, but there are 2 different components. And today, it's very clear that users need wallet, right? The very first step on anyone's journey to the blockchain is actually centered around the wallet. The first time you want to use the blockchain, you are supposed to create a wallet. I remember, the first question is, do you have a wallet? If not, please create a wallet. So the wallet is really front and center. And when you create that wallet, it comes with a lot of complexity, right? You need to install or download the software, which actually is kind of weird. I came to do X, and I'm supposed to install Y. Why should I do that? Then you need to back up a seed phrase, you need to on-ramp to pay transaction fees. There's a lot of complexity, and the wallet is really front and center of that first user experience. But the thing is, the fact that users need wallet doesn't necessarily mean that users want wallet, right? We tend to forget that, but we are early adopters of that technology. And so we can live with a little bit of complexity. And I would argue that for many of us, actually, we want to see that complexity. We want to see the underlying technology. I remember the first time I interacted with the blockchain, I wasn't there to do something specific. I wanted to interact with the blockchain. That's really what I wanted. And so it was completely OK to install a software to interact with the blockchain. I was in for the technology, not for something specific. And so we've come to believe, and I think that's a mistake, that the next billion user, and the next billion user is kind of this mythical bunch that we like to throw at conferences to represent the next wave of people that will come. We tend to believe that this next wave of users will be exactly like us. We picture them as a bunch of zombies just desperately needing a wallet. And I think that's a mistake. So we should ask ourselves, what actually do normal users want? And I believe normal users, they don't want wallet, they want applications. Because in the end, they don't really care about the technology. The next wave of users, they will come to do something. Maybe they will come to play a game, and it so happens that that game has a component running on the blockchain. But they are not there for the technology. And in a sense, I think many of them will not care about the technology. They will only care about the application. And so when you take a step back, we're basically creating an ecosystem that looks like this. We have application, we have the account on chain, and then in the middle, front and center, you have that object called the wallet. But that's interesting, because what users really want is actually the application. But we also know that the protocol needs the account. So there's basically that beast in the middle that nobody really needs and really wants. So I do think that we should try to make that center component invisible. And that's why we should make wallets invisible. But what does that exactly mean? What would be that dream experience of an invisible wallet? Well, I think the first thing is that there should be nothing to download or install. If you want to make it invisible, there's no way for me to install something that I want to make disappear. So there should be nothing to download. Of course, you should be able to onboard in seconds. Right? You should create an account for the users in seconds. there shouldn't be any complex concept that users need to understand, like a seed phrase, transaction fees. All this is very complex. If you want to make the protocol as invisible and the wallet as invisible as possible, that complexity needs to be abstracted. Of course, we want to have some kind of simple account recovery. The very reason we have seed phrase is to help users recover their account if they lose it. So if you want to make that complexity disappear, we need to find ways for users to recover their account in case something goes wrong, and that should be very simple. I also believe we should have some kind of fraud detection, because the blockchain is still a dangerous space sometimes, and so if we want to make the wallet, the protocol as invisible as possible, we need to help users to make sure they have safe experience. They can explore the ecosystem in a safe way. And so there needs to be some kind of safety nets. I also think everything should be one click. Again, if you hide the protocol, whatever interaction you want to do, you're supposed to do, it should be very seamless. It should be one click. You shouldn't have to understand, I need to approve X to do Y. No, you want to do an action because all this is transparent, invisible. You want to do an action, you click on a button, and that should be it. I also think there should be less moment where the user has to be conscious about the technology. That means less signing of transactions. Okay, so that's an interesting list. But actually what I'm describing is, for example, signing to Coinbase. And indeed, Coinbase is doing an amazing experience for normal users. Why? Because it's a Web2 product. And it's a great onboarding experience because the technology is completely abstract. It's basically not there. It's a Web2 product. So this list is okay, but it's not enough, of course. And so we should not forget that what we want also is to have self-custody. We want to have all these properties, but at the center, we want it to be self-custodial. So is this enough? Well, not completely yet. There are companies that actually provide this self-custodial Web2 kind of boarding, such as Sorare. They do an amazing job. But actually, when you do so, you only create a wallet for Sorare. So this product, they are application specific. What we want, you want the same experience, but you want the users to being able to go from one application to the other. If someone comes to, say, play a game, it so happens that it's on-chain, so they log in with that invisible wallet. At some point, they receive some NFTs. Maybe they will want to take these NFTs to another application. So they should be able to port their identities and their asset seamlessly. So that's still not enough. We also want the ability to port the account to multiple dApps. And so if you look at this list, there's actually a tension between making everything invisible and very seamless, but at the same time having self-custody. And this tension is actually complicated to solve. But the good news is I think there's something we can use, and that's actually account abstraction. Account abstraction, I believe, was the missing piece to enable that experience. So Vitalik gave a great talk about account abstraction 2 days ago, so I will not talk too much about account abstraction. I want to focus about what we can do with account abstraction. But just as a recap, the idea of account abstraction is to being able to program the functionalities of an account. Today, an account on Ethereum does 4 things. It validates the transaction, it executes the transaction, it pays a fee to the miner, and then it makes sure you cannot replay this transaction to abuse the account. And on Ethereum, all this is hard-coded. The idea of account abstraction is to make that customizable so that you can really program your account. And concretely, that means your account is a smart contract. And so you can really change the underlying cryptography, or you can have multiple signers. I mean, just your imagination is the limit. And so that's kind of theoretical. So visually, I like to, when I think about account abstraction, to picture it like this. So again, I have my client wallet, which may hold a key, for example, some cryptographic material, and it manages and controls an object on-chain, the account. And that account contains some custom logic. And so when I make a transaction as a user, I will use that key in my client wallet to sign something, send that to the contract, and the contract will execute whatever custom logic I've decided to put in my account. And if everything is OK, we'll call the dApp. So let's use that model to kind of see what we could do based on that. So the first thing to realize is that because you can program your account, there's actually no need to say a transaction is just one call to a dApp. We could actually say that a transaction executes a sequence of operations. So for example, I can say with this transaction, I will first call a token to approve some dApp. Then I will call the dApp, and I will use whatever output to call a third dApp. All this can be orchestrated in the logic of my account. And using this concept of multi-call, actually, that means everything becomes one click. Any complex blockchain operation that may require 6 or 7 interactions with different contracts, you can actually make it in just one call using account abstraction. Okay, so that's actually one check on our list. So far, so good. What else can we do? Well, we can also basically abstract transaction fees and sponsor transactions. There's different ways to do that. But one way is to use the concept of a paymaster. The idea of a paymaster is, let's think of a dApp that wants to make it free for its users. So the dApp is saying, I'm willing to pay the transaction fee for any users that interact with my dApp. How would they do that? They basically deploy a specific contract called a paymaster. And every time a user through a wallet wants to interact with that dApp, the wallet can actually create a transaction that says, you know what, I'm not going to pay for that transaction, he is going to pay. And so the protocol will check with the paymaster, are you okay to pay for that transaction? The paymaster will execute his logic, say yes, and will subsidize the transaction for the user. So again, using that, we can completely abstract transaction fees. What else can we do? I mentioned that we should have a simple account recovery, because of course we need to get rid of seed phrases. So how do you do that? If your account is a smart contract, you can, for example, program it to have a second key, and you can choose to give that key to some service. Let's call it a recovery service. And that key is not the same as the main one. It cannot do transaction to transfer token. It cannot mint NFTs. It can do only one thing, is help you recover access to your account. So the day something bad happens, you lose your wallet, so you've lost that primary key. What do? You call that service. You authenticate yourself and say, hey, I have a new key that I want to authorize you to authorize on my account. And the recovery service can do, the only operation it can do is reprogram your account with a new key. So that's a very simple flow, and it completely removes the need to back up seed phrases. And of course, you can choose to create an account with one key that you give to a service, but you can also choose to have a ledger, or maybe you can actually have 2 or 3 guardians. I mean, you can do what you want, but the point is that you can create a flow that's very simple and that allows users to recover access to their account. What else? I mentioned that we should try to help users navigate the blockchain, the ecosystem in a safe way, but again, using account abstraction, you can imagine that you program your account again with a second key. You give again that key to another service that you call a fraud monitor, and this time the rules of your account specify that this key needs to co-sign every transaction. And so now as a user, when you interact with the dApp, you will send the raw data of that interaction to that service, and that service will analyze the transaction based on rules such as the target contract being flagged as a scam. Or is it a contract you've already interacted with? What kind of assets are going to leave the account and be returned to the account? So this fraud monitoring service can really use any logic to basically try to determine if the transaction is going to be safe for the user. If it determines that the transaction is safe, it will just provide a second signature, and it's completely transparent to the user. You click on a button, your transaction goes through. But if the service detects that the transaction may be suspicious, for example, you are transferring 95% of all your assets to an address you've never interacted with, maybe it is legit, maybe not. And so the fraud monitoring service can basically ping you, give you a 2FA challenge, and say, is it really you, the owner, triggering that transaction? If you say yes, it will co-sign, and the transaction can go through. So again, using account abstraction, we can really enable 2FA challenges and really have fraud detection, but really happening on-chain, with the control on-chain. Another thing we can do based on that model is do something like session keys to reduce the amount of approvals that you need to do. Again, playing with this idea of account abstraction, you can imagine that when you go to a dApp, the dApp will generate a key locally and ask you to approve that key on your account under certain conditions. So the dApp may say, I want this key to be authorized for 25 minutes, and it can only call this method on that contract, and it can only consume, say, 50 DAI. So all this is really written, is signed by the user, returned to the dApp. And next, the dApp can use that token to actually prove to the account that it's a legitimate operation. And so after that, every single action that you do, every button that you click, you actually no longer need to sign or approve anything. There's actually no more wallet. The dApp can directly call your account to execute the transaction. So that makes the wallet completely invisible, and you know that this operation is actually secure because it's within the perimeter of what you've allowed the dApp to do. And finally, another thing that we can do that is interesting is you can actually go passwordless, for example. We can use a concept such as WebAuthn. Why? Because we can program the account. We can actually program the account to use a different type of cryptography that we usually use. And today on your phone, on our phones, we all have a secure enclave, a hardware component that can actually sign things. It has keys, it can sign, but it signed that on an elliptic curve that is typically not recognized by most blockchain. But because you can program your account, you can actually make your account support that different cryptography. And so you can turn your phone into a signer with a component that is never exposed. And you can use something like WebAuthn or passkeys. So just to recap, I've tried to convince that users actually want application, they don't want wallet. And so we need to make the wallet invisible, to make the operation, the onboarding and the usage of blockchain as transparent, as seamless as possible, but we need to keep something essential, self-custody. And hopefully I've also tried to convince you that to resolve that tension between a seamless experience, making the wallet disappear, and maintaining this key property of self-custody can actually be achieved through account abstraction by using techniques such as multi-call, account recovery, sponsored transactions, session keys, and so on. And the good news is that this is not theoretical. We can actually do that today, and actually we are doing that today at Argent, and we've released this week a product called the Web Wallet on Starknet, and I even have a cool video to show you how it works. And so it really looks like a Web2 login, an experience that most users would know. And that's it. In 2 seconds, using an email and a password, you are connected. You can actually browse, go from one dApp to the other. And this is just to highlight that it's actually very simple for developers. You can clap, you don't need to clap, that's fine. Jakub, the guy who makes our video, will be happy because he's doing a great job. But anyway, so the point is to say that all these things, they are not theoretical. I think we've reached a point of the technology where we can actually make this experience real. And I personally find that very exciting. So if that's something you find exciting as well, please reach out. If you're active in the Starknet ecosystem, please reach out. We would love for you to support this new product. And it's actually already live on some dApps. So if you're a developer, you can scan that fancy QR code, and that should give you access to all the details on how to actually support that on your application. And if you want to just play with the ID, I invite you to go to either Brick or Starknet ID, Carbonable or Avenue, and create a wallet with an email, and you will be actually able to use that experience. And finally, as a side note, the contracts have been audited, and actually the application has been audited as well. So this is, I think, a great concept, and I hope we'll see these kind of ideas more often in the future. Thank you. Shut. Hello, hello. Yeah.
Hello, thank you very much. Could you go into more details in how the paymaster would work technically, please?
Yeah, so the paymaster is a concept that was introduced in the IP 4337, and that is today implemented on zk-Sync era. It is not yet implemented on Starknet. So that's what I mentioned. There's different ways to sponsor transaction. But the paymaster is basically a smart contract that people can deploy. And it's really written at the protocol level. When you make a transaction, you can actually specify that you will be paying 0 fee. You know, on every transaction, you typically say how much fee you are willing to pay as a user, and you sign that. With the paymaster, you basically say, I'm not paying anything, but you provide an address. of who is going to pay for you. And the protocol will take care of that. So at the moment where the protocol typically pings the account to say if the account is going to pay, which you do through validate, it will call the validate method to make sure that the account is willing to execute that transaction. But at the same time, it will also call a validate method on the paymaster that you have provided to check if that entity is willing to pay. And if the output of that call is yes, the fee is punctioned from that address and the transaction is executed. Yeah.
Hi, so my question, so it's not exactly account abstraction, but the opposite. So I wonder if Argent has any plans to support also Bitcoin.
Ooh, that's a wide question. Short and long answer, no. No, we British Ethereum, and this is the ecosystem we want to support. So we have no plan to be on Bitcoin. There's also some limitation because we are a smart contract wallet. We need to have a smart contract language, and we need a chain that can support all these flows that we are creating. But Bitcoin wasn't there. I think it is gradually moving in that direction, but so far it has never been an option, no.
Hi, thank you again. I have a technical question regarding account recoveries. You mentioned there is a first key that are only able to sign transaction and a secondary key to change this first key. What prevents me to change the first key for someone else?
So basically the idea of recovery, or social recovery, as we called it when we launched that in Ethereum 5 years ago, is to say that you have a primary key, the owner key, and that key has full control on the account. And so that key can actually add other keys that we call guardians. And these guardians, as I mentioned, they can only do one action, is to help you recover access if something goes wrong. And so you can have multiple guardians and they need to sign with the majority, but imagine you only have one guardian, so yes, the question is what is the power of that key? The thing is that you always remain in control. So if that guardian key, for example, starts to abuse your account and trigger a recovery that you did not want, you can actually cancel it. So there will be a notification. Of course, this is happening on chain, so you need to monitor what's happening, but we do that for you, and there are services doing that. So you can basically detect that your guardian is doing something he's not supposed to do, and you can cancel the recovery. Because what I didn't mention is that it's a bit more complex than that. We are using time periods, for example, to make sure that everything is, is safe. So when the guardian triggers a recovery, the recovery is actually only executed on L1 it was 2 days, on Starknet it's 7 days after it has been triggered. And that means you have that period to basically detect that event and cancel it if it was triggered by a raw guardian, basically. So the idea is really for you to stay in control and to have true ownership. So if you want, you can check on our website, there's more detail. But I mean, this flow has been securing hundreds of millions of dollars on Ethereum since 2018. So, and there's never been a hiccup.
Okay, thank you.
When the user creates its wallet, who pays for the contract's deployment?
That's a very good question. The way it works is that actually when you onboard the first time, your account is created counterfactually, meaning that we use create2 to determine where the account will be created, but actually it is not created. So as a user, you see just an address. And of course, and at some point you created that account to do something, right? So you need to do a first transaction. And typically for that, you need to being able to pay fees. And so it's at the moment of that first transaction that we bundle it with the deployment of the account. So for the user, it's completely seamless. The user never sees that he needs to create an account. It's completely seamless, but at the time of the first transaction, the fee for that transaction will be a bit higher because we are deploying the smart contract at that moment.
Thank you.
I think that was the last question, so thank you.